we are on to our last two functions, secant and cosecant. And actually, if you can graph sine and cosine, these are equally as easy. So here's how it works. We actually are going to start off by graphing cosine, and you can already see I have it down here, y equals cosine. And I've wrote it in yellow because it's going to help us graph what we want to graph here, but it's not actually going to be part of the graph. Okay. And I want to remind you of this also, right? Y equals secant of x is equal to 1 over cosine of x. And I want us to start off at some easy points, like let's say right here. Well, if we did 1 divided by the y value here, right, that would give us secant. So 1 over 1 is 1. So secant at 2 pi is actually also equal to 1. And actually, all these peaks and valleys are going to wind up also being on the graph of secant. Okay? And let's check this one here too, right? The y value here is -1, and so if you do 1 over that, you get -1. Okay, so all those red points are points in common between secant and cosine. All right, next, let's think about what happens at, say, points like this. So here the y value is 0, so it's going to be undefined. And you can do the same little experiment that we did with tangent, and what you'll find is that at this point, 7 pi over 2 that we're looking at, we're going to have a vertical asymptote. And in fact, all those locations where the y value is 0 for cosine, those are all going to be vertical asymptotes for secant. Right? Because all these points will be doing 1 over 0. And one last asymptote here. And the next thing I want you to do is maybe let's focus in on this little interval here in between these two asymptotes. Why do we have a vertical asymptote here? Well, let's just imagine that we're moving along the curve in this direction and we're heading towards pi over 2 here. Okay. Right? Well, secant, right, is 1 over cosine. So you're going to end up with 1 over smaller and smaller numbers. Okay. And right, if you do 1 over a small number, you get a big number. And so since those numbers on the bottom are getting smaller and smaller, the result is bigger and bigger and bigger. Okay. And so we do get an asymptote here, and the same thing happens on the other side. Let's go ahead and sketch that. Let me get rid of a little bit of this though. There we go. All right, and so this is one of my favorite ones to graph just because it's so easy. We're just going to continue making those little almost U-like shapes here. And so in the red there, we have y equals secant of x. Easy thing to kind of get mixed up on here is for tangent and cotangent, you could find the period by just finding the distance between two consecutive asymptotes. Well, that is not the case here, because for one full period to be completed, right? I need 2 sets of asymptotes, not just one, okay? To complete one cycle, you need one of these, one's facing upward and one of the ones facing downward. So as what we've graphed here is 2 full periods. And we're going to go do the same thing with cosecant. And so this time, we're going to be thinking about the graph of sine, which I already have plotted here for us. And the same thing happens. So at these spots where sine is 0, cosecant will be undefined. And there will be vertical asymptotes there for the same reason we had vertical asymptotes on the graph of secant. All right, and once again, we'll do the exact same thing. We'll put these little U shapes at the top of every peak and at the bottom of every valley here. And this is y equals cosecant of x.